Okay, so imagine you walk onto a factory floor today. You see these amazing robots, right? Welding arms, assembly bots, little transporters whizzing around.
Yeah, designed for incredible precision, incredible speed.
Exactly. But then picture this.
Yeah.
Maybe half are from one company, half from another. And here's the kicker. They just can't coordinate.
Right. They don't speak the same digital language.
So that transporter, it needs a part from an assembly bot, but nothing. They can't communicate.
Hmm. Or think about your smart home. You know, your fancy robot vacuum finishes the living room.
Yeah.
But if it's from a different maker than your main smart home system,
Right.
it just sits there. It can't report it's done, can't ask where to go next.
Which isn't just, like, annoying for you. It's actually a huge drag on efficiency, isn't it?
Oh, absolutely.
Hmm.
For businesses, it's lost time, lost money. It slows everything down.
And it really limits what we can actually do with all this amazing robot tech. It's this communication gap between machines from different companies.
That's the bottleneck.
So the path forward, and this seems pretty clear from the sources you shared, is some kind of universal language for these robots.
Exactly.
And that brings us right to what we're digging into today, the R2R Protocol, Robot2Robot.
R2R, yeah.
It sounds like more than just a name. It's meant to be this standardized system to actually break down those barriers, right? To get us towards a truly unified robotic world.
That's the goal. A common tongue.
Okay, so our mission for this deep dive, let's unpack what R2R actually is, how it works based on the sources, and really get why it's so crucial for, well, the future of robotics.
Sounds good.
All right, so let's dive in. This R2R thing. What's the core idea? How does it actually create this universal language for machines that could be totally different under the hood?
Well, fundamentally, R2R gives them that common ground. It's a shared set of rules, a shared vocabulary that any robot, really regardless of who made it or what it does, can use to swap information instructions.
So like a base dictionary and grammar.
Kind of, yeah. The sources use this analogy, and it fits quite well. It's a bit like Esperanto, but for robots.
Ah, okay. That makes sense. Trying to bridge the gaps.
Exactly. Just like Esperanto aimed to be this neutral, easy language for humans, R2R aims to let robots from, say, company A talk to robots from company B without needing, specific custom translators built for every single pairing. That's just not scalable.
Right. That would be a nightmare. So how does it do that? How does it make sure the messages get across clearly?
The key is structure. R2R defines a really, really structured format for the messages robots send back and forth.
Okay.
These aren't just random bits of data flying around. Think of them more like standardized digital forms, pre-printed almost. Every piece of information has its designated spot, its specific meaning.
Like filling in boxes on a form.
Pretty much. And that structure is what guarantees clarity, precision, that makes sure that when one robot says something using R2R, any other R2R compatible robot can understand exactly what it means.
Okay, that structure is definitely key then. So if we peek inside one of these digital forms, these R2R messages, what are the essential parts? What are the building blocks?
Right. The sources lay out the core components. First up, you've got the message ID.
Okay.
Think of it like a unique tracking number, a serial number for every single message.
Crucial in a busy environment, I bet.
Absolutely critical.
Yeah.
Imagine hundreds, maybe thousands of robots all chattering away. You need a way to tell each message apart, track it, make sure it gets processed correctly. It's about the integrity of the whole communication flow.
Got it. Unique ID. What else?
Then there's the message type. This tells the receiving robot the basic purpose of the message.
Like, is it an update?
A command.
An error?
Exactly.
Yeah.
Is it just saying, hey, I'm at location X, that's a status update? Or is it move to location Y, that's a command? Or maybe, uh-oh, something went wrong, an error report. Or even a question, what's your battery like?
And knowing the type helps the receiver prioritize, right? Figure out what to do with it quickly.
Precisely. The sources emphasize that for efficiency. Next, context. The sender ID.
So who sent the message? Like a return address.
Exactly like a return address. Knowing who sent the info or the command is vital, especially if robots are working together on a task, or if something goes wrong and you need to know the source.
Makes sense. And I guess the opposite is needed too.
Yep, the receiver ID. Who the message is for.
Can that be specific, like Robot 7? Or more general?
Both, actually. It can target one specific robot, or it can use a broadcast address, like sending it out to all robots in a certain area, or all robots of a certain type, like all charging stations nearby.
Okay, that flexibility seems important for different kinds of coordination.
Definitely. Then something simple but critical. the timestamp.
When the message was sent.
Exactly. Down to the millisecond, usually. In these distributed systems, knowing the precise timing is essential. It hosts sequence actions, synchronized robots. Imagine two robots trying to grab the same part based on slightly old information. Chaos.
Yeah, timing is everything. Okay, ID, type, sender, receiver, timestamp. What's the actual message content?
That's the payload. This is the heart of it, the actual information being sent.
So the sensor beta, the coordinates, the battery levels.
Right, so whatever the message is about. Could be sensor readings, specific coordinates for a move command, that battery low status, detailed info about an object it detected.
Now here's what seems really interesting based on the sources. For this to be universal, that payload can't just be raw data dumped in there, can it?
No, absolutely not, and that's a crucial point. The payload itself needs to follow standardized formats, or what we call data schemas.
Okay, explain that a bit.
So if Robot A sends its battery level, it needs to send it in a way that Robot B, from a different maker, knows exactly how to interpret it. Is it a percentage?
Yeah.
A voltage? What are the units? The schema defines that structure within the payload.
So a thermal map from one robot looks like a thermal map to any other R2R robot.
That's the idea. Standardizing the content structure inside the payload is honestly a huge part of the challenge, but also where R2R gets its real power for interoperability.
Wow, okay, so it's not just the envelope, it's the standardized letter inside too.
Exactly. Put all those pieces together, the IDs, type, sender, receiver, timestamp, and that structured payload, and you get a message that's complete, unambiguous, and understandable by any robot playing by the R2R rules. It moves beyond just connecting them to actual meaningful understanding.
Okay, I think I'm getting the structure, the sort of the grammar and dictionary of R2R, but let's make it concrete. How does this stuff actually work in the real world? The sources had some good scenarios, right?
Yeah, they did. Let's walk through them. Take scenario one, the delivery robot running low on juice.
Right? Okay, poor little bot out on the street.
Right. It detects its battery is getting critical instead of just, dying quietly. It uses R2R. It puts together a status message type, status, sender ID itself. And the payload contains that key info, maybe structured like battery level 5%, following the agreed R2R schema for power status.
And who does it send it to?
It might broadcast it using a general receiver ID that nearby charging stations are listening for.
Okay, so the charging stations are also R2R compatible. They hear this cry for help.
Exactly. A nearby station picks up the message, it parses the payload, sees battery level 5%, realizes, hey, that's low, and maybe checks its own status and location relative to the robot.
And if it's the best option?
It sends a message back. Message type, command, receiver ID. The specific delivery bot that sent the status message, sender ID, the charging station, and the payload. Something like Navigate to, followed by its own coordinates, again in its standard format.
And the delivery bot gets that, understands it because it's R2R, and just heads over.
Yep. All automatic, seamless charging coordination thanks to R2R.
Cool. Okay, what about the factory example? Collaborative work.
All right, scenario two. Imagine a tricky assembly task. Maybe it needs two different kinds of robot arms, and they happen to be from different manufacturers.
A common problem, I bet.
Very. So, robot arm A is working along, and it hits a part it can't quite handle by itself. Maybe it needs a special grip that arm B has.
So arm A needs help.
It sends out an R2R request, message type, request assistance, sender ID, arm A. The payload would specify the details. Task widget assembly, needed capability, precision grip, location station 7.
And it sends this out. How? To a specific robot.
Could be broadcast, or maybe it knows arm B is nearby and sends it directly using arm B's receiver ID.
Okay, and arm B gets the message.
And because it speaks R2R, it understands the request. It checks the payload. Precision grip needed at station 7. Yep, I can do that.
So it replies.
It sends back an accept request message. Type, accept request, sender ID. Arm B receiver ID. Arm A payload might just be ready to assist at station 7.
That's like a digital handshake.
Exactly. And with that R2R agreement, arm B moves over, and then they coordinate the actual task using more R2R messages, commands, status updates working together in a way that would be impossible if they couldn't understand each other. Big productivity boost.
Yeah, you can see how that unlocks complex tasks. Okay, one more of the smart home.
Scenario 3. Your robot vacuum finishes the living room. Hoovering done.
Right.
It sends an R2R message. Type, task complete, sender ID, vacuum bot 5000, payload, room, living room, status clean, standard format again.
And it sends this to?
The central smart home hub, or controller. That's the receiver ID.
And the hub understands R2R?
Yep. It gets the task complete message, reads the payload, living room, clean, It checks its own internal schedule, maybe looks at its map of the
And it
house.
figures out what's next.
Right, maybe the kitchen needs doing. So the hub sends command back to the vacuum. Type, command, sender ID, hub, receiver ID, vacuumbot 5000, payload, navigate to, kitchen, task, clean.
And the vacuum just gets it and goes. No fiddling with different apps.
Exactly. It receives the command, understands the R2R instruction instantly, and off it goes to the kitchen. Minimal human needed. Seamless flow between devices from potentially different brands.
These examples really drive it home. It's not just theory. It's about enabling practical, useful coordination in homes, factories, cities.
Absolutely. R2R provides that essential connective tissue, that common language, to make these kinds of complex autonomous interactions actually work smoothly.
Now, the sources also hinted that just defining the protocol on paper wasn't the whole story.
Wow.
Actually getting robots to use it effectively. That sounds like a journey in itself, an engineering challenge.
Oh, for sure. It's one thing to write the standard, quite another to implement it robustly in the real world. The sources mention a few key stages, sort of milestones in getting this communication working properly.
Okay, like what?
Well, first, there's just getting the first real R2R conversation going.
The proof of concept.
Basically, yeah. Can Robot A actually send a message using the protocol? And can Robot B receive it and understand the basic structure? It sounds simple, but you're dealing with potentially different hardware, different software stacks.
Yeah.
Just getting that first handshake to work across vendors is a big step.
Right. Ironing out the basic connectivity.
Then the sources talk about completing the robot dialogue. This sounds like going beyond single messages to defining the whole interaction flow.
The back and forth.
Exactly. If a robot sends a request, what are the valid responses? What happens if there's an error? How do you handle confirmations, cancellations? It's about defining the expected sequences, the sort of conversational etiquette for machines, creating robust interaction patterns.
So it's not just words, it's full sentences and paragraphs, metaphorically speaking.
Kind of, yeah.
Yeah.
This leads to the next point, ensuring smooth communication flow.
Performance. Reliability.
Seems like it. How does the system handle real-world network issues, latency, dropped packets? If you have hundreds of robots chatting, how do you manage the bandwidth? How do you make sure critical safety messages get through instantly, while routine updates can maybe wait a bit? It's about making the communication practical and reliable under pressure.
Making it work smoothly, not just theoretically.
Right. The difference between knowing the words and speaking fluently,
Gotcha. And the final step mentioned.
Packaging the language. This sounds like pulling everything together.
The whole shebang.
Yeah. All the message definitions, the dialogue patterns you worked out, the rules for error handling, all those crucial data schemas for the payloads, implementation guides for developers. Basically, compiling it all into one comprehensive, usable standard, like the official R2R dictionary and grammar book that manufacturers can pick up and use.
Creating the definitive guide.
That seems to be the idea.
And once that's done, once it's packaged and robots are actually using it, the sources call this a giant leap for robot kind. It sounds pretty significant.
It really is.
Yeah.
Because it's not just that robots can now ping each other. It's that they can have these meaningful, productive exchanges, conversations that enable whole new levels of collaboration, autonomy, efficiency, things that were just impossible or incredibly expensive and clunky to achieve before with custom integrations for everything.
You're unlocking coordinated behavior on a massive scale.
Exactly. That's where the real value lies. It empowers robots to be true participants in a connected system. And that, in turn, paves the way for much closer, much more sophisticated ways humans and robots can work together, too. You're not just dealing with isolated machines anymore.
Okay, so let's try and wrap this up. Summing up this deep dive, it feels like the R2R protocol isn't just some technical detail. It's really foundational, isn't it?
Absolutely foundational. It's the linchpin for moving towards that future we imagine, integrated, efficient, interconnected robotics. It's the key step needed to let all these different robots actually work together.
Breaking down those digital language barriers allows them to share info, coordinate frictionlessly, ideally.
Right. Giving them this common communication ability isn't just fixing a compatibility headache. It's fundamentally enabling a new era. It changes the game for what's possible when machines can finally understand each other properly.
So a final thought for everyone listening. Thinking about the machines already around you, or the ones coming maybe at work, maybe in your city, maybe even in your home. What new possibilities really open up in your world when those machines can finally speak the same language?